GS is this one. This is Y. This is GHS. Okay. So we have a 0 at s equal to -1. We have a pole here, and we have a pole here. Okay. So we have 2 poles and 1 0. But these are called the finite poles and zeros. Okay. There is also another 0 which happens as s moves to infinity, right? Because if s is moving to infinity, what is going to be this term? It's going to become 0, right? So this is called infinite 0, right? So we have 2 poles that are finite, 1 0 that's finite, 1 0 that's not finite or infinite. Okay. So let's apply the rule that I mentioned about the real axis, right? So we said that, okay, if k is equal to 0, k equal to infinity, k equal to 0, and the other 0 which happens here, it's going to be k equal to infinity. So to the left of odd number of poles and zeros, we have a root-Lucas branch on the real axis. So here we have only one. To the left of it, we're gonna have a branch. Okay. Do we have a branch here? No, because we have 2 poles and zeros here. Do we have a branch here? Yes, we do, because we have 3 poles and zeros. Do we have a branch here? No, because we have 0 poles and zeros to the left of it. So here, this is very simple now. This is actually our root-Lucas. If k is equal to 0, the closed loop, one closed loop pole, it's gonna be here, and it's gonna move towards -1 as k increases from 0 to infinity. The other pole of the closed loop system, it's gonna be at -2 when k is equal to 0, and it's gonna move to negative infinity as k goes to infinity. Okay, so this is basically these 2 lines shows like how poles of the closed loop system are gonna move. How many poles does the closed loop system have? It has 2. One of them moves from here to here as k changes. The other one moves from here to infinity as k changes. Okay. Now, is the closed loop system stable? It's going to be stable if k is bigger, is like if our closed loop, if this pole, it's going to be on this side, right? So we have to find what this value is, right? At what value k, it's going to be, k, what's the value of k where s is here, okay? So again, this one is not that difficult. We can just use this formula. K, it's gonna be 1 over g of s, gh of s, right? So for this system at s equal to 0, because at this point s is equal to 0, s is j omega, right? So at this point, the frequency is 0. So at this point, if I put 0 here, we have 1 divided by 1 multiplied by 2. So at this point, k is going to be equal to 1 over 2, which becomes 2. Okay. So this pole is always on the left-hand plane, but you remember that for a system to be stable, all the poles have to be on the left-hand plane. So if k is bigger than 2, both poles of the closed loop system are going to be on the left-hand plane, right? So the system is going to be stable, right? That's how Root-Lucas is going to be helpful to tell us like if the closed loop system is stable or not. Okay. One more example. In this one it says s plus 4, sorry, s minus 4 times s minus 3 divided by s plus 1 multiplied by s plus 2. The first thing we do again, like we draw the s-plane, real, imaginary. Identify the poles and zeros of the GS, GHS, GS times GHS. So we have 2 zeros on the right hand plane at s equal to 3 and s equal to 4, and 2 poles on the left hand plane. Okay, so this system is stable, but we want to figure out if the closed loop system is stable or not, right? So let's again look at that rule that tells us like about the location of Root-Lucas branches on the real axis. So first of all, when k is equal to 0, one pole is going to be here. When k is equal to 0, one pole is going to be here. We're going to have 2 poles, right? As k is equal to infinity, one of the poles is going to be here, moving here, and the other one is going to move here. Okay. Now, also, at this on here we don't have any line. Here we have a line because we have one pole here, or sorry, 1 0 here. We don't have any line here because we have 2 zeros here. We have a line here because we have 3 poles and zeros here, and no line here. Okay. So we said that one pole, it's gonna start moving from here. The other one, it's gonna start moving from here. One pole, it's gonna end at this point. The other one, it's gonna end at this point. Okay. So somehow one pole, it's gonna come here and then moves to either 3 or 4. The other one also the same thing. Okay. I'm not gonna prove this, but most of the time the Root-Lucas branches are either straight lines or it's gonna be in the form of circular